The science of a rocket launch.
A rocket launch is a delicate balance of physics, engineering, and precise calculations. Every successful mission follows the fundamental principles of motion, first defined by Sir Isaac Newton. As the engines ignite, the rocket remains motionless until an external force is applied. This is Newton's first law of motion. An object at rest stays at rest unless acted upon by an external force. The force? The controlled explosion beneath the rocket, generating thousands of kilonewtons of thrust. As the rocket climbs, Newton's second law takes over. Force equals mass times acceleration. The more thrust the engines produce, the faster the rocket accelerates. Engineers carefully adjust the thrust to maintain the correct trajectory. At 50 kilometers above Earth, gravity weakens, but it still holds influence. Newton's law of universal gravitation states that the force of gravity decreases with distance. However, reaching space requires more than just height, it requires speed. At 100 kilometers, the rocket approaches the Kármán line, the official boundary of space. To stay in orbit, the spacecraft must reach an incredible velocity, about 28,000 kilometers per hour. This is where the final burn happens.
With the last engine ignition, the spacecraft reaches orbital velocity. At this speed, Earth's gravity and the rocket's momentum balance perfectly, keeping it in a stable orbit.
This is the science of spaceflight, Newton's laws in action, guiding us beyond our planet and into the vastness of space. The universe awaits.